Have you ever wondered if there are things buried deep beneath our planet that even science can't explain? Objects so advanced, so precise, that they completely defy everything we know about human history. For decades, scientists around the world have stumbled upon discoveries that shouldn't exist. Artifacts, structures, and technologies that seem far too complex for the civilizations that supposedly built them. Some of these findings are hidden in remote deserts, deep ocean floors, and forgotten ruins. Each one raises the same question: who or what could have created them? Because when you look closely, the precision, scale, and purpose behind these discoveries make one thing painfully clear. No known human tools or methods could have achieved this. Keep watching as we uncover 6 discoveries that scientists themselves admit no human could ever have built. Number 1. The Voynich manuscript.
The fact that the manuscript is written in a way that nobody else could read it suggests that it is preserving knowledge that someone wanted to keep secret.
The Voynich manuscript sits in a museum vault and resists any simple explanation. At first glance, it looks like a book. Open it, and you find page after page of drawings and handwriting that do not match any known script. The images show plants that are not in any botanical guide, charts that mix body-like figures with circular diagrams, and slender lines of flowing script that run across every page. The ink and binding show care and planning. The pages are arranged with sections that suggest topics. The book was found in Europe and dated to the early 15th century by material tests. That dating means the manuscript is not modern. It also means someone, long ago, invested a lot of time, materials, and skill to make it. What stands out first is the repetition and order in the text. The characters repeat in patterns that resemble what you expect when a language is written, including recurring groups of letters and apparent word breaks. That pattern rules out random scribbles. It also rules out a trivial hoax made at a single sitting. Whoever wrote the manuscript used a consistent set of signs and a clear page layout. That points to a system. The obvious question becomes, what system? Linguists, code breakers, and statisticians have treated the manuscript like a locked door. They have measured letter frequencies, compared patterns to known languages, and tested whether the sequences match natural speech. The answers keep pointing back to an unsolved problem. The text behaves like a language, but resists translation. People have proposed many options. One view is that the book encodes a dead or isolated language we simply cannot compare to anything living. Another view is that it is an invented script with a clear grammar and vocabulary that once made sense to a small group. A third view argues it is a deliberate hoax, written to confuse or to sell as a curiosity. Each idea runs into trouble. If it is a hoax, the amount of consistent detail across hundreds of pages is hard to explain. If it is a natural language, we would expect repeated phrases that map to known concepts like numbers, names, or common verbs. Many statistical tests show the manuscript's patterns look closer to real writing than to random text. That keeps the classic riddle alive. It looks deliberate, but the meaning is missing. The illustrations add another layer. Many plant drawings do not match species in botanical records. Some appear as hybrids of known plants. Others are completely new. The human figures in bathing pools and strange circular charts do not match clear scientific diagrams from that era. They suggest a mix of medical, herbal, and astronomical information. But it is not the same mix we see in medieval herbals or medical books. That mismatch leaves room for theory. Either the book records a local practice that vanished, or it documents an imagined system created for reasons we do not grasp. The careful drawing style argues for a serious project, not a casual notebook. Technical attempts to break the manuscript keep returning partial results and more questions. Computer models that compare letter patterns can show statistical likenesses to certain language groups, but those likenesses do not produce consistent translations. Scholars who have spent years on the book find that single words appear in multiple contexts where a normal language would use related terms. Translators claim small breakthroughs, but none pass peer review in a decisive way. Even modern machine learning tools, which excel at pattern recognition, cannot give a stable, credible gloss of the pages. That produces frustration. Modern tools can parse faint handwriting and restore damaged text. In the Voynich case, those tools clarify the shapes but do not supply meaning. The practical effect is clear. The manuscript is a test case for how we handle lost knowledge. It forces an examination of how languages die, how specialized knowledge can disappear, and how much of the past remains close to us because we lack parallel records. It also shows the limits of material science. We can date inks and fibers, but we cannot always recover the human context behind a written object. The manuscript sits where object and mystery meet. It is a book that proves a group of people once put an organized message on paper. What that message said, who they were, and why their record failed to pass into other archives remain open questions. The manuscript is not just an unsolved code, it is a problem that touches on history, linguistics, and the practical limits of reconstruction. Number 2. The Antikythera mechanism.
It was not recognized at all as being anything interesting when it was discovered. It was just a corroded lump about the size of a large dictionary.
The Antikythera mechanism is a physical object with parts that fit together in a predictable way.
Anything from ancient Greece simply shouldn't have gear wheels. These were precision gears with teeth about 1 millimeter long.
It came out of a shipwreck found off a Greek island. Divers pulled fragments of corroded bronze and wood from the wreck. At first, the pieces looked like lumps. After cleaning, researchers found toothed wheels, bronze plates, and complex gear trains. Over time, the fragments revealed numerical dials and schemes that correlate to the motions of the sun, moon, and some planets. Researchers used X-rays and later 3D imaging to see how the gears fit. With careful modelling, they showed the machine could predict lunar phases and solar and lunar eclipses. That conclusion shocked scholars because it implied a working mechanical model of celestial motion existed 2,000 years ago. The part that changes standard narratives is not merely that gears existed. Small gears had been known, in one-off machines, or as parts of simple devices. The Antikythera machine shows a multi-gear assembly built to calculate. The gearing is precise enough to require that its makers understood tooth ratios, gear spacing, and durable assembly. That level of mechanical thought suggests a tradition of skilled work and shared knowledge. The puzzle becomes, why do we not see more examples? If such precision existed, why are there not more machines, workshops, or texts describing their construction? One answer is preservation bias. Complex gearwork made of metal corrodes in many environments. Another is limited use. Perhaps the mechanism represented elite knowledge, built in small numbers. But even solid explanations do not remove the core puzzle. The device sits in a gap between technological skill implied by the object and the archaeological record of continuous development. Scholars have tracked possible lineages. Ancient Greek philosophers wrote about mechanical devices and automata. Some engineers in Hellenistic cities made water-powered machines and clock-like devices. Yet the scale and complexity of the Antikythera machine indicate careful design, not improvisation. Reconstructing the machine today required reverse engineering. Physical replicas show that a small team of trained artisans could have built one. But making these parts in large numbers would need an industry of tool makers and foundries. That industry should have left traces, molds, workshops, or textual manuals. The lack of those traces is a real gap. The implications are practical. The Antikythera device changes how historians consider the spread of technical knowledge. It suggests pockets of advanced craftsmanship could exist without widespread diffusion. It also forces historians to re-evaluate peripheral evidence, literary references to devices, passing mentions of engineers, and coastal shipwrecks that might have carried technical goods. Finally, the mechanism highlights how a single object can reshape historical questions. It asks for careful fieldwork aimed at locating similar artifacts and for a technical history that explains why certain skills appear and then vanish from the visible record. Number 3. The Baltic Sea Anomaly. The Baltic Sea Anomaly began as a sonar image. A private survey crew mapping the seafloor found a round shape that stood out from the surrounding sediment. The object is large and roughly circular. The sonar returned clear lines that suggested flat faces, steps, and a ramp. Those features led to immediate speculation because they do not match typical rock formations or ship debris. Media coverage fueled wild theories, but the technical reports tell a steadier line. The object has features that are unusual and not easily classified by remote imaging. Divers who reached the site reported unexpected experiences. Some said their equipment flickered. Others reported strange noises and an odd silence. One diver became ill. These personal reports complicate scientific assessment because they point to either local environmental factors or anecdotal effects that are hard to reproduce. A proper response requires controlled, repeated surveys, including magnetometers, sub-bottom profiling, and careful sampling. That kind of work is expensive and logistically demanding in deep, cold water. The initial survey team lacked the resources for a full technical campaign. That left the site in a state of partial knowledge. Scientific caution matters here. Natural rock formations can take on odd shapes when currents, glacial action, and sediment deposition act in combination. In some instances, concretions and methane-related features produce neat faces. In other cases, human-made objects like concrete structures or ship parts get buried and then uncovered in ways that make them look unusual on sonar. The Baltic object resists easy matching because its surface looks carved, and because local reports mention electromagnetic effects. Those two strands require separate tests. Magnetometers and electromagnetic surveys can map anomalies in a reproducible way. If instruments show consistent readings that deviate from background noise, that points to a material difference. If repeated dives reproduce the same diver effects, that would add weight to the initial reports. Until controlled data exist, the Baltic object remains an open file, a clear, unusual sonar target with anecdotal reports that push interest but no publicly available, rigorous dataset that clarifies composition or origin. That situation is the key point. Unusual finds do not become evidence until someone documents them with standard protocols. The anomaly remains a candidate for serious study, one that will only be resolved with time, funding, and careful measurement. Number 4. Cusco's Precision Wall.
This royal city sits high above the Sacred Valley of Peru, South America. The Inca believed that these mountains were gods.
Outside Cusco, a wall stands as a physical statement about skill and planning. Large stone blocks meet with tiny gaps. The fit is tight enough that no mortar is needed. The surface of each block bears marks of careful dressing. The blocks vary in size, some so heavy that moving them without modern cranes would be a major task. Yet the builders achieved a joint quality that resists earthquake shaking. The wall has survived many centuries of natural strain, while neighbouring masonry failed. That fact forces attention on the builders' goals. They aimed for strength and longevity. Archaeologists place the wall in an Inca context. The Inca did work extensively with stone, and they built roads, terraces, and storage houses that used precise stonecraft. What makes the Cusco wall notable is the level of finishing on each block and the three-dimensional interlocking that anchors the mass into stability. The work required planning. The builders had to measure, cut, and position each stone so that it matched its neighbours in 3 axes. That level of planning implies teams with clear roles: quarrying, shaping, transporting, and placing. Each step required technique that may now be partly lost to us because written records are absent. Field researchers studying these walls combine practical experiments with archival work. Experimental archaeologists try to match the fit with period tools and local techniques. They show that with time, patience, and simple implements, skilled teams can reach high precision. The experiments also show the central role of trial and refit. Workers would place, mark, remove, and recut stones in iterative steps until the fit matched. That method consumes labour, but yields durable results. The lesson is straightforward. Given labour and organisation, pre-industrial societies could reach impressive technical ends. The wall, therefore, offers a corrective to models that equate tool absence with low skill. It shows that a people without iron or wheeled cranes could still produce engineering that lasts. The site also matters for social history. A wall like this signals social organisation capable of mobilising labour and resources for public works. It suggests not only craft skill, but administrative systems for quarrying, transport, and site control. Archaeological work that ties the wall to roads, terraces, and settlement patterns gives a fuller picture of how such engineering fits into daily life. The wall is an artifact of technique and of social capacity, and that dual nature explains why it remains a focus of study. Number 5. The Fire Eagle's Nest, Siberian Stone Mound. In eastern Siberia, there is a mound that local people treat with caution. The feature is a tall cone of stone with a smooth dome at the top. The ground around it shows signs of burning and crushed rock. That combination does not match common river or glacial forms in the region. Scientists have proposed several options, including a powerful underground explosion that shattered the bedrock and piled the fragments into a cone. The Tunguska event of 1908, a large atmospheric explosion that flattened trees over a wide area, provides a comparative case, though the Siberian mound differs in scale and local pattern. What complicates study are consistent reports of equipment failing and workers feeling unwell near the site. Those reports could reflect environmental hazards such as gas emissions, magnetic disturbances from unusual minerals, or even local pathogens. They might also involve cultural storytelling that gathers around a striking landscape feature. The straightforward scientific response is to measure, sample, and test in a controlled way. Gas probes to check emissions, magnetometers to map fields, soil analysis to test for high temperature alteration, and controlled drilling to sample the subsurface. That kind of campaign will show whether the mound is an impact or explosion feature, a piled talus from erosion, or an artificially built structure. The local context matters too. If the mound is ancient and linked to human activity, then excavation could reveal artifacts, post holes, or cultural layers that clarify purpose. If it is natural, samples will show shock alteration or signs of a rapid thermal event. Either outcome is useful. Right now, the mound sits in a gap between field reports and technical results. That gap keeps the mound in the category of serious anomaly that invites but has not yet received the kind of controlled study that settles questions. Number 6. Ancient metal pipes of Western China. In the dry basin of Western China, reports describe metal tubes embedded in rock as if they are part of a system. These tubes appear in a region with ancient human habitation, but the claimed age of the pipes in some accounts predates known metalworking on the scale suggested by their form. Where the pipes meet the rock, samples show mineralization and cementing that suggest long burial. Some reports describe T-shaped joints and branching lines which imply design rather than random mineral growth. Skeptics point to natural processes. Certain geological formations produce cylindrical cusps where organic roots or buried logs mineralize and leave hollow tubes. Groundwater moving metal ions can deposit metals into cavities, and create what looks like metal coatings on former plant material. Those processes produce curious shapes, but they rarely produce regular cylinders with clean seams and welded joins. That is why the site resists an easy classification. Resolving the matter requires detailed materials science. Metallurgical analysis will show composition, crystal structure, and traces of heating. If the metal shows alloying and tool marks consistent with human work that supports a manufactured origin, if it shows layered mineral deposition and a lack of human shaping, that supports a natural origin. In addition, strict geological context is essential. Dating the surrounding sediments, mapping stratigraphy, and comparing the tubes to regional mineral deposits. Only tight, reproducible data will move the site from rumour to settled science. Until that happens, the pipes remain an open question that highlights how field claims need to meet laboratory tests before they change our timeline for technology. If these discoveries made you question what we really know about our past, don't forget to hit the like button and share your thoughts in the comments. Subscribe for more mind-bending stories like this, and we'll see you in the next video.